Welcome back. So, this is the last module for this particular lecture where we were looking at the op amp and using the op amp as several circuits. What we have used? We have used op amp as an inverting amplifier, we have used op amp as a non inverting amplifier, we have used op amp as an summing amplifier, we have used op amp as an integrator. Now, we will see how the op amp can be used as a differentiator. Of course, we have also used op amp as a unity gain amplifier, right, unity gain amplifier, and we have tried to solve several problems and we found the solution how can we solve the problems, and most of the things that I am teaching you in the theory class I will also show you as a part of the experiment class, as a part of the experiment class. So, now if you can come back on this slide, what you see is a differentiator, what you see is a differentiator. So, if you have seen the last module, what was that? The capacitor, the integrator was a circuit where your this R was having capacitor and this capacitor was having a resistor, right. You remember? You do not remember? See, integrator, right, capacitor is here, differentiator, integrator, differentiator. See, so just by changing the position of R and C, I can form a integrator and differentiator circuit, alright. So, differentiator, what is differentiator? Differentiator is a circuit whose output is proportional, to the negative differential of the input voltage, right. The differentiator is a circuit whose output is proportional to negative differential of input voltage with respect to time. So, if I want to write the equation for VO, my output voltage will be nothing but minus RC into dV in by dt. Okay. Now, since the current through R and C are same, again this same thing, right, my current through here and that current through here would be same, right. I can write down this current equation for this particular for this one and V in C into dV in by dt equals to, from here what is it one, minus VO by R, So, from here I can find the value of VO will be the equation of VO will be minus RC dV in by dt, very easy, extremely easy, right, extremely easy. Now, for a given circuit, for this circuit, determine the output voltage of differentiator circuit as shown in figure. Assume that the input voltage is 3.5 volts and time constant is 1.5 milliseconds, alright. For a given value of input voltage and given value of time constant, what I had to find? I had to find the output voltage. So, it is very easy because I know the formula. I know that VO equals to minus RC dV in by dt. I already know that VO is nothing but minus RC into dV in by dt. So, if I substitute the value of VO, substitute value of R, substitute value of C, right, and I already know what is V1, right, then I can easily find my output voltage VO, and when you solve it you will get the value of VO equals to 1.65 sin 100 pi t volts, right. So, if you are given an example of a differentiator, such that a sine wave 1 volt peak to peak at 1000 hertz is applied to a differentiator with the following specification, RF is given, C1 is given, find the output waveform, So, what is given? That if I apply a sine wave 1 volt peak to peak at 1000 hertz, right, to a differentiator, right, and I know what is value of RF, I know what is value of C1, find the output waveform. Okay. So, given this value is given, V in equals to sine wave, right, sine wave 1 volt. So, Vp into sine the omega t equals to sine into 2 pi into 1000, right, into t. So, output of voltage differentiator is given by this value. When I substitute the value, I will find that VO is nothing but minus 2.07 into cos 2 pi 1000 t. Thus, the output waveform looks like one shown here, right. So, if you have this formula for output voltage, your output waveform would be this, right. So, we will see again by applying different voltages, by applying different waveforms of the at the input of the differentiator, we will see how we can get the different waveforms at the output of the differentiator. Alright. So, what we have seen? We have seen the op amp as a differentiator, and then we have seen the example of operational amplifier as a differentiator. Alright. So, in the next lecture we will concentrate on using op amp as a filter, alright, op amp as a filter circuit. So, now the op amp can be used for several applications, and one of its application is filter. So, we will see how we can design filters and similar kind of filter circuits and similar kind of this amplifier circuits, whether it is a inverting, non-inverting indicator, differentiator, summer, right, unity gain amplifier. We will see the examples how we can implement those circuits on the breadboard, or we will also see a software called Simulink, and we will see how we can do how we can perform this simulation, right. So, that will give a little bit more understanding on how the circuit can be implemented, what kind of equipment you can use, and how you can design a particular circuit using operational amplifier. Alright. So, till then you understand what exactly differentiator, you once again see how we can solve a problem for a differentiator, and then in the next class, in the next lecture, we will see how the op amp can be used as a filter, whether it is a passive filter, whether it is an active filter, and there are several type of filter that we will be discussing in the next lecture. So, till then you just look at the whole lecture where you have understood how the op amp can be used as an amplifiers, alright. So, till then you take care, and I will see you in the next lecture. Bye.